Welcome all to the BSG debate. This is actually one of several debates taking place at the annual meeting this year. This has been part of a conscious effort to try and embed more open discussion in the meeting. Geomorphologists and the society at large need to be engaged and to be seen to be engaged with topical issues that are of relevance to both science and society. So thanks to all of you here for attending and to all of you out there that are watching this as part of a live stream on the internet. Now, before introducing the panellists, off to my left here, in a few introductory slides, I just want to set the topic for debate in context, particularly for those of you that are perhaps unfamiliar with the Anthropocene term and related issues. So it has, of course, long been recognised that human activities have the potential to influence Earth's surface processes, landforms and the broader landscape. Early civilisations in North Africa and the Mediterranean knew the problems of human-induced erosion and sedimentation, for instance, and in some cases devised land use strategies to cater for this. Detailed, more scientific studies started to emerge in the latter part of the 19th century and early 20th century, prominent among these being the work of George Perkins Marsh, culminating in his book, Man and Nature, Physical Geography as Modified by Human Action, and Grove Carl Gilbert's studies of mining impacted streams in the Sierra Nevada. Were they alive, both of these individuals would hopefully be happy to be identified as or with geomorphologists. At about the same time, terms were being proposed to account for this interval in which human activities were seen to be impacting to an ever greater extent on the Earth, but for one reason or another, terms such as the Anthropozoic, the Psychozoic, and the Noosphere never really caught on. In more recent decades that one might associate with the development of modern geomorphology, geomorphologists have continued to document how a range of human activities influence Earth's surface processes, landforms, and landscapes. This Woolman's classic study of the impact of rural-urban transformation on sediment yields, for instance, and a range of other terms have been proposed to account for this interval of human impacts on the Earth. But again, none of these terms have really caught on widely. By contrast, the Anthropocene, first used by Paul Crutzen, who's a Nobel Prize-winning atmospheric chemist, first used this back in the early 2000s, has caught on like a wildfire. This is a term and concept that argues that humans are now such a dominant geological force shaping the Earth's surface, and importantly, in ways that will be preserved in the geological record, that we've entered a new geological age. In effect, the Holocene may have ended, and we are now all living in the Anthropocene. In the natural and physical sciences, particularly geology, ecology, the atmospheric sciences, quaternary sciences, this is an open, albeit highly contentious debate. And conferences have been held and special publications written to debate the concepts. In the social sciences, this seems to be less so. The term Anthropocene has caught on, in fact so much so that it seems to be on the point of going viral, with conferences, competitions and blogs all considering the implications for things like society, nature, interrelations, human behavioural changes, and indeed even morality. One question that remains: where is the geomorphology, or indeed where has the geomorphology gone? Where are the geomorphological considerations in deciding whether and how to define this putative new geological age? And where are the geomorphologists engaged with the debate? In essence, geomorphologists seem to have been sidelined from the main debates, perhaps talking to ourselves using related terms and concepts, but not really at the main party. So for this reason, the BSG initiated the Anthropocene working group, largely under the drive of Tony Brown here on my left. And its remit is basically to embed and promote geomorphology as an integral element in the Anthropocene debate. Outputs to date have included an Essex commentary, shown here, which is freely available to all BSG members via the Wiley-Blackwell website, and an online questionnaire, available here at the link indicated. Now, some members have completed this with informative comments that have really helped us to shape our discussions and deliberations at working group meetings, but we need more of you to do so. Or to contribute in other ways, indeed, through the questions this afternoon. So, on to the debate. Late last week, no doubt someone with Gareth Bale's recent transfer to Real Madrid in mind, someone had tweeted, "Come to the BSG meeting and meet the Galacticos of geomorphology." And we have Tony Brown, Professor at the University of Southampton, who's convener of the BSG working group on the Anthropocene. He has research interests including floodplain geomorphology and paleohydrology, alluvial geoarchaeology and forensic palynology. We have Simon Price in the middle there from the British Geological Survey. He's the team leader of their urban geoscience project. He has research interests including artificial ground, 3D modelling of the urban subsurface, and urban geoarchaeology. And we have Andreas, Professor at the University of Liverpool and President of the Division of Geomorphology of the European Geosciences Union. He has research interests including geomorphology and geochronology, particularly in the context of examining Earth's surface response to environmental change. So in essence, we've got a spectrum of opinions here from across pure and applied geosciences. Now, all of the speakers have been asked to base their talks around the three problems which are alluded to in the Essex commentary, and all of which are important practical considerations in any official formalisation of the Anthropocene, should it take place. We have the relative magnitude problem. How do we assess and quantify claims that humans are having a dominant, overriding or overwhelming influence on the Earth's surface? We have the spatial diachrony problem. Even if a case can be made for human dominance, to what extent has the onset of this dominance varied in its timing around the globe? And related to this, we have the boundary problem. If we recognise this spatial diachrony in the human impact, how do we define the start of any putative Anthropocene? And indeed, what are the implications for its formal stratigraphical status, e.g. as an epoch or stage? So each of the three panellists will hopefully talk around the three problems from their own perspectives. We've had a minimal amount of communication regarding the content of this slide, so it remains to be seen where points of agreement or indeed disagreement lie. And of course, we'll debate these with contributions from the audience afterwards. So without any further ado, let me hand over to Tony Brown and talk about geomorphology and the Anthropocene.
Thank you, Stephen. The starting point for this debate in considering whether the Anthropocene should form a geological epoch is, of course, that geological epochs have to be visible and represented within the rock record, within the geological record. And so, therefore, we have to start really with the geomorphology, because, of course, it's geomorphology that drives the rock record fundamentally. And that's why geomorphology, of course, has to be central. So, as Stephen alluded to, we've also got the first question, which is the human versus natural erosion, and I'm sure that you will recognise these diagrams. What we're dealing with here is the unintentional, at this stage anyway, the unintentional impact of humans, largely through altering vegetation at the surface of the Earth, and their effect on the erosion rate, increases in erosion rate per capita during the Holocene, which was from Hook back in 2000. Noted is, of course, per capita, so we have to multiply that up, of course, by population. Then we have, for example, the agricultural soil erosion rates, greatly exceeding other or many other processes through the importance of tillage, and certainly exceeding long-term geological rates, or regarded as exceeding long-term geological rates, and also soil production rates. This, of course, is the idea behind there being effectively a limit on productive capacity, which, when exceeded, can cause societal collapse, which is quite an important but very problematic area, both within archaeology and geomorphology. And we can put these two together, and that's what really was done by Wilkinson. We can say, well, there is a point at which, if we do our budgeting, if we add up all our columns and and assuming we've got, of course, our sums and columns correct, they should really, of course, have quite large margins, in fact, very large margins of error on them. But let's for the moment ignore that, and if we add them up, then there will be a point at which is related to human population, the total mass moved in relation to the Earth's surface by humans inadvertently and on purpose would exceed the natural surface erosion rate. And so that's the basis of saying that, therefore, it would seem to me, following Cruxham, that humans might be the dominant agent in terms of geomorphological mass transfer. It's not the same as processes, of course. So if we do have, and it appears that there is basically a consensus that humans are the dominant geomorphological factor on the Earth today, therefore that would be a geomorphological Anthropocene as defined by Cruxham. And of course it does immediately beg the question as to when this would have occurred. Now, we have to now jump back to this question about the geological record, because we've also got to see this in the geological record for it to be a geological epoch under the existing rules of stratigraphy, unless of course we're going to throw them out, which we'll come back to. And I think we do have this. I mean, there are lots of geomorphologists in this room and elsewhere who've looked at fluvial systems. I know most about fluvial systems, but also slope systems. And the picture that you see up there is of a piddling little river in the West Midlands of England called the Frome, and it has 5 metres of alluviation, which basically is just sandy silt that was dumped on the floodplain, and it was dumped on the floodplain after the Bronze Age, and there's absolutely no doubt that it was stimulated by almost 100% agriculture of the slopes around the floodplain. And this happened on very sandy soils, and the result is mass alluviation. And this is a completely different geomorphological unit and geological unit, therefore, as if we go back into previous interglacials, we will not find a unit of this size within, or capping our channel fills. Underneath it, of course, is a, if you like, a natural floodplain. And there are other examples here. There's an example from Germany. There's another example from the Midlands in England. And we've dated these. We now regard these as an artifact of human activity. And if they're an artifact of human activity, then they're clearly anthropogenic. So therefore we have a bounding surface. And if you can correlate this, of course, from one catchment over to another catchment, that puts it in terms of formal stratigraphy and sedimentology up to about a 5th order bounding surface. And if you have a 5th or a 6th order bounding surface, then you can start to define a geological discontinuity which would form part of, so the base of a new epoch. So formally, that is where you could say that it lies. Now, it's not just in Western Europe that this has been pointed out. If we go back to remarkably work by Happ, really, and Gilbert and Leopold, they of course realised that this was also the case in North America. We have this bounding surface. We know that the sediment budget system altered dramatically with the sweep across the northern United States of European-style cultivation. And so we can see that this has been picked up more recently by Walter and Merritt, again, dramatically altering all fluvial landscapes in North America, or practically all, and producing this very, very recognisable anthropogenic unit with soils underneath it of the natural floodplain. It's also more increasingly, it's also being recognised in other areas of the New World. So there's some work here from Australia, where we can see a post-settlement sedimentary response, and also most recently, and rather interesting because it's so early, is a post-cultivation response in Central Africa from work in Mali. So the more that we can trace this across the globe, the higher order it becomes in relation to being a geological boundary. What's driving it? Well, basically, the transformation of the Earth's surface. This is, of course, it's a model basically by Jed Kaplan's group, and I've picked out one particular time window from 1000 BC to about 300 BC, when the vegetation of Europe is dramatically altered. The vast majority, that is, all the places that except for the places that were too steep or too unproductive for agriculture. And so we see this process, obviously, of transformations of catchment from a relatively natural, not entirely natural, but relatively natural state, often forested, depending on the biome, of course, with its associated flora and fauna, to the situation now where we have about 85 to 90% of the Earth's surface, one would argue, has been transformed in some way or other. Not all, of course, by, cultivation, but through, for example, other land uses such as grazing, which also, of course, alters the Earth's surface characteristics. And it's fundamentally driven by agriculture. So if we came back to the Earth in 1 million years' time, which is, of course, one way of viewing it, what we would see would be this sedimentary boundary, one would argue, And one side of it, below it, we would have a certain faunal biozone, faunal and floral, and above it we would have a totally different one, which has reflected the extinctions and, of course, cultivars, but also synanthropic organisms. So dramatically altered both the biological and the geological and geomorphological landscape. This leads, though, to some interesting problems. One of them, which I'll just highlight here, which we would have to consider, almost irrespective of where we put the boundary, although it becomes more of a problem if we put the boundary perhaps earlier than later, is why have the Holocene? Now, the Holocene's base was only formally defined, in fact, in 2009, and it's an unusual boundary because it's based on the ice core. It's not defined in terms of a global stratigraphic stratotype that you can go and see. And it, of course, basically marks the end of a cold cycle and the beginning of an interglacial. But in that respect, it's no different from the many in the 100K world, perhaps rather different from those in the 41K world, but certainly not in the 100K world, that went before it. The Holocene, though, is fundamentally different in the sense that it is demarcated, and if we go back to the original citation of its identification, because it is the period under which we had human, the evolution of complex society and a fundamental change in the relationship between humans and the Earth's surface dynamics and climate. So it's already sort of part of the Anthropocene is sort of slightly already embedded in the Holocene. So that's an interesting question. And this has perhaps been highlighted more recently by the attempt by the Quaternary fraternity to divide up the Holocene. Again, using basically climatic or global climatic markers. In this case, the 8.2 event defining the early to middle Holocene, and then the 4.2 event to define the middle to the late Holocene. So we're recognizing here subdivisions which could be basically regarded as series within an epoch. So if we do adopt the Anthropocene, does this make the Holocene basically a boundary or a transition of about 5,000 years, which is roughly the precision of earlier geological boundaries largely based on paleomagnetics? It's about 5,000 years. So are we actually living in a boundary, or does it make the Holocene redundant? So these are questions which will naturally follow and are important in our discussions in relation to both geomorphology and its relationship to geology, earth sciences more generally. And of course, one of the reasons for being in this debate is that we must take a much more active role in the broader discussion of this within earth sciences. Okay.
Okay, so I'll hand over to Simon Price from the British Geological Survey.
Thank you. Good evening, everybody. Well, what I'd like to do now is actually talk about the direct, intentional ways that people shape and sculpt the landscape, affect patterns of sedimentation, and create landforms. But before I do that, I just want to refresh and let us think about the two main ways that people shape and sculpt and affect the landscape. So on the one side, we've got indirect transformation. So that's where the impact on sedimentation is a consequence of another activity. So things like construction of dams, agricultural soil erosion, deforestation. So sediment flux is affected as a secondary effect of a primary activity. The second part is the bit that I'm going to focus on for the rest of the talk. That's direct, intentional movement, transport, and use of material taken out of the ground. So that's through things like mineral exploitation, urbanization processes, waste disposal. But the key thing is that each process has the potential to create a distinct layer or a landform associated with it. But let's think about that in a little bit more detail, and we can think about the varying degrees of anthropogenic influence in two different ways. One way we can think of it in terms of the effect that people have on depositional environment, and on the other side we can think of anthropogenic impact in terms of the composition, the lithology of the sediment, the lithology of the landform. and there's an interaction between the two. And this is a diagram with some photographs to illustrate some examples. So if we take number 1 in the top right of the corner there, that's completely manufactured processed material. It's actually ceramic waste from Stoke-on-Trent. So it's deposited in a landfill site, it's completely manufactured anthropogenic material. If we take number 3, it's fluvial deposits deposited in an environment that's not affected by people. But it's really the stuff in between that gets a little bit more complicated and a little bit more interesting. Take another example, number 2, down on the bottom right there. That's completely natural, reworked material, but it's actually used, or it's ready to be used for construction fill. So it's an anthropogenic process, but completely reworked natural material. So what about the scale of that, especially if we consider the types of deposits that fall on the right-hand side of that diagram? Well, if we take an example from Great Britain, and we start to map out those deposits that dominantly fall on the right-hand side of that diagram, and we look at those areas in light grey and dark grey, and they're actually the distribution of those types of deposits shown on geological maps. Now, I admit it's an underestimate because not all geological maps show those deposits. Anyway, it gives us an idea of the spatial extent and significance of these deposits. And we can think about the volumes as well. If we just take one element of that associated with mineral exploitation and overburden, then for Great Britain we can calculate that the volume of material deposited in around about 200 years, about 66,500 million tonnes of material, about 40 cubic kilometres. But we can scale that up to the world. So we can look at the world's major, around 50 mineral commodities, and the overburden associated with getting it out of the ground. And we can start to plot that and look at the volumes of material and the weight of material added to global sediment flux over that time. So if we take 2010 as an example, we're adding in here another 100 billion tonnes of material just in 1 year. Of course, overburden really strongly affects these figures, which has changed through time. That's not the whole story. If we think of things like concrete and cement that are being manufactured as towns and cities grow, we can probably add on another 80,000 million, another 80 billion tonnes of material. So taken together, for 2010, the amount of material deliberately moved by people exceeds that of sediment transported through the world's major oceans by about 10 or 12 times. But the other important thing to recognise is the rates of processes, the volumes of material, the numbers of landforms has actually changed through time as well. So we recognise that in the past, we recognise it in the UK, for example, in Roman and pre-Roman times, but it's quite local and it's not widespread. And it's not until the Industrial Revolution that we really see the rapid expansion of those processes and those deposits. And again, it's not until post-Second World War that we see another acceleration. So, we talked about the deliberate impact of people and the sedimentary response of that, but how can we recognise that signal and that signature now, and how might we recognise it in the future? Well, in the geological record, one way that we do that is on the basis of stratigraphy. So we group similar rocks and sediments together. And we use different criteria to do that. So it could be changes in fossil assemblage, numbers and types. It could be changes in mythology. It could be flips in the Earth's magnetic field, that kind of thing. But the point is that we recognise those criteria, changes in those criteria, in different places around the world, and we recognise the boundaries. But if you think about it, for the Anthropocene, we're kind of going about this in the opposite way, where we've proposed an epoch, and now we're trying to define the characteristics of it. So we're kind of working in a funny way here. So we should really only define that boundary, first of all, if it's useful to do it, if there's a benefit in doing it, and also if it's equivalent to things that have happened in the past. So I don't think that there's any doubt about the significance of deliberate human impact on the landscape. But whether we choose to bracket that as a completely new epoch, or whether it's a defining characteristic of the Holocene, well, does that really matter? And importantly, what this shouldn't really become about is defining an ultimate golden spike as a stratigraphic horizon to try and find. Thank you.
Thanks, John. Last but of course not least, we have Andreas.
Hello from me, and let me take you to a landscape that might not be that spectacular, but certainly has a rather early start of the Anthropocene. And I'll try to bring you into Central Europe, into loess covered landscapes there, characterized today by single-thread meandering rivers that are completely artificial, and that at least since 2000 years. So when we think about boundaries and geological boundaries, we just heard that we need an unconformity, so erosion process is happening, and we need a sedimentary deposit. And both of those are available in these landscapes. We have widespread soil erosion. In many areas, soils completely missing, like you can't hardly see it. Anyhow, here is thus a Pleistocene deposit directly overlain by a ploughing horizon without any soil left. And there was about 2.5 meters of soil before agriculture started at that place. And if you go from a location like that just downslope, here we find a wedge of sediment, slope-derived deposits, colluvium, where in several cases we have 4, 5, 6 meters of deposits that are all derived from erosion further upslope and have been moved down into those positions. Same, of course, or similar picture we find in the floodplains. So if you look at a cross-section through a floodplain, we have pre-quaternary and late Pleistocene sediments. Sitting within that is a channel fill, or a fill of the valley bottom. If we look into that in detail, and here is an age versus depth plot, and the histology is given in the background. You can see that in the late Pleistocene, early Holocene, we have very rapid infill, peak growth in channels that have been left over from the younger dryas fluvial system. After that, we have very little happening for quite a long time. Soil formation, an organic rich floodplain soil was forming for 6,000–7,000 years. Before then, around about the Roman period, things changed, and suddenly the whole system was completely drowned in fine deposits. The river certainly was no longer able to cope with the sediment load that was derived to it. So we have a transformation from a wetland area that probably didn't have a proper river in it, but was just a connection of ponds, into something that's now a confined, single-thread, meandering river in cohesive sediment. We can quantify these things, and we can look at the amount of material removed. We can compare how much has been eroded on different parts of the slope. We can look at how much has been deposited in the colluvial footslope, in the first and second order alluvial deposits, and how much actually was exported to higher order streams. And for those loess hill areas, one characteristic is that about 50% of the materials eroded didn't really reach the rivers, but is still stored at the foot slopes, and then, some of that is exported into higher order streams. And if you spend a lot of time on quantifying things like that, you can actually derive a value for, this is the whole of the Rhine catchment. So here we have about 100 10⁹ tons sediment stored due to unintended human usage of the landscape in the slopes, and about half of that in the floodplain. And just to show that the order of magnitude is comparable to what we've just seen in the talk before, it's about 3 times the amount of intended materials moved across Britain, in the last 150 years. So, if we think about Anthropocene, we can clearly show that we have a widespread unconformity, and that can be followed through not just diverse areas, but also the adjacent upland areas. We have a lithostratigraphic unit that is sitting on, well, depot centers in valley bottoms and at the lower slopes. We clearly have a significant reshaping of the landscapes. Much of that landscape has a relatively subdued topography, and human action has reduced that topography by a third to a half in places. And we can also see that the functioning of the river systems has completely changed. And that is an interesting thought if you think about, well, the Water Framework Directive, for example. If we really want to go back to a natural state, we need to go back a long time, at least 2,500 years. The spatial differences here are also followed, of course, by a temporal difference. We have clear evidence of erosion at least since the late Neolithic period, so 5,500 years ago. We have widespread evidence of foot-slope columbiation from, well, at least the Bronze Age, so 3,500 years ago. And then the floodplains start to react since the Iron Age. In many places, the late Iron Age transition to the medieval period is an important part, so about 2,000 years ago. So the spatial diachrony is, well, the temporal, diachrony is quite substantial. Thank you for your attention.
To me, I think it's really important for us as geomorphologists. I feel this very strongly because all that Anthropocene is changes on the Earth's surface in response to human activity, which is behaving in a geomorphological fashion. It's a geomorphological event. The fact that it's having stratigraphic significance, in my opinion, is really a matter for sorting these out. It's not really the size. It's those people who want to put things in order, put it in a nice place, but it's not dealing with the particular processes that we're concerned with, which concern our life now, the past, and in the future. And I think we have got a duty to bring home to the world how important it is to understand how geomorphology needs to be understood for the future of human beings on this planet. I feel it's very strongly here. I think there's no more important science. And I think we've therefore got to have a strategy to make our mark. Because if we don't, it'll be taken over by others who will take over the role and do it less well. I've seen this throughout my career where things that geomorphologists should have been doing, we've gone with our own way, others have taken it over, and they've received the funding and they've done it far less well than we have. And I think we need a strategy for taking this to the research councils to get the appropriate funding that we need to underpin government actions, both in Europe and in Britain. We need to deal with national bodies such as National England so that they understand also the geomorphological role. And in that sense, I speak as I'm the Earth Science representative on National England's Science Advisory Committee. And believe you me, it is hard work getting through to the rest of them how important the Earth's surface processes are. They want to know, but they start from nowhere. And so I think it's very important that we work at this hard to do what I think is our duty as geomorphologists, as the people who have the fundamental role in understanding the way the Earth's surface will work, has worked since the times you're talking about take place, and will work in the future while we're on the surface of the Earth. So that's what I think very strongly indeed about it. Absolutely like so he's taking this initiative and tracking it through. Thank you.
Perhaps I can draw in one of the other panels. Andreas or Simon, do you want to respond to maybe Jim's point there?
Yeah, Jim, I think that's, regardless of the formal debate about what the Anthropocene is and what it might be, what it might look like, what its boundaries might look like, all that kind of thing, I think one of the things, and it's whether it's geomorphology or geology or earth science, one of the useful things about it is that it's provided a link from geomorphology and earth science to people. And I've always felt that, you know, when you consider things like biodiversity, there's much more public awareness of things like that for whatever reason. But people are always interested in people. And I think that's one of the good things about this, is that it does actually provide a really good opportunity across the sciences to actually engage the wider public in understanding that, because they can relate to the kinds of things that we're talking about here. Oh, right, that had that impact, and I see that. So I think the informal side of it, albeit as a, I don't want to call it a brand, but just as a topic to discuss around, I think it raises that awareness.
Andreas, you got anything to add on to that? That's about funding, or from your European perspective, perhaps?
The real point here is that the debate is ongoing and has been ongoing for quite a while. I mean, since Crutzen first came up with the term, and even in the atmospheric chemistry community, that was not an undisputed term. There was a response by Rüdiman that placed the beginning of the Anthropocene much earlier, and basically to the start of the agriculture. So our work really can contribute to that by trying to reduce the uncertainties that are currently existing when we think about greenhouse gas emissions pre-industrial revolution, and to try to resolve if the global atmospheric chemical signal may be early and maybe human related as well. So that's the one side of the debate that's already happening, and this is one where I feel, should contribute to, because, as you say, it's our science, it's our discipline that cares about the Earth's surface. And on top of that now comes the whole other debate, linking it to geological units. And again, it's geomorphic processes that form and shape the geological units. So again, we need to be part of the discussion.
I want to come back to Heather and a question for the bar.
Thank you. I just wanted to really make a point and raise a question about the spatial diachrony topic here. And I really wanted to pick up on some of the really interesting quantification that all three speakers have presented today. Because it does strike me that that's surely one of the contributions that geomorphologists have already made and really need to continue to make. I mean, these things absolutely bring it to life. I've scribbled down a whole series of hard facts here, which I went too fast for. But this notion now that in certain parts of the world we're able to specify what happened, when, and what kind of record that's left, I think is really fascinating. And I just wanted to leave with a question, really. To what extent do we have good records from other parts of the world, from geomorphologists and quaternary scientists?
Back to Tony, I think.
Well, I think the pattern of our knowledge is really related to what we were trying to do. I mean, it's very historical, isn't it? I mean, really. And therefore it is interesting that if you go into some of the areas where people are looking at now at early agriculture, see whether you can find a response in these, Mali being the reason I showed that. And it follows also that there may be some places where there is no response. And that's very itself the part of the diachrony, isn't it? Because of course, as I think Stephen has said before, there may be some parts where geomorphologically the Anthropocene has never happened and may never happen. So that is part of that diachrony. But I think that our historical pattern of looking fundamentally far more in North America and Europe has rather clearly constrained that. And the more that we look in different areas of agricultural expansion, the more we'll get a broader and better pattern of that diachrony.
Question about Abby Stone on the far side.
Leading on from the point about diachrony spatially, but also the changing nature through time. So what Andreas was describing with the sediment, it's going to be a very different signature than finding increased heavy minerals or plastic nodules or cities preserved. So how do we deal with the shifting nature through time as well as the diaphanous nature across space.
Good question. Simon, perhaps you want to start on that?
Yeah, well, I think that it's a defining characteristic of the kind of things that we've talked about, absolutely. And actually, it's not unusual in the geological record to have that diaphanaity present as well. So quite often we recognise, even in the existing geological record, that those kind of things happened at different times, and you recognise that signature in different areas. So it's one of the defining characteristics, but in the debate about defining boundaries, because it's already used, I mean, Tony hinted that actually those guidelines that are produced by ICX are actually quite heavily pushed around and moved in how they're applied to existing geological periods and epochs in that hierarchy. So the diachronaity argument actually doesn't really hold for the Anthropocene because it's actually already used elsewhere in the geological record.
Can I say something? I think there is a very important difference that you're alluding to, and that is that as geomorphologists, we're obviously interested in geomorphological processes that move, that erode and deposit, etc. And when we move into effectively, let's call it main ground, or all that includes the positives and the negatives, the holes, the drilling, the oil, the cities, they're not driven by geomorphological processes in regard to the transfer and the location of the transfer and the time of the transfer. I mean, fundamentally, they're the result of cognitive actions by humans. And that therefore, leads to a very interesting question. Is this potentially, is it, in a sense, the end of geomorphology? Because if the majority of the world's mass is actually being moved around as a result of cognition, then what's the point of, if you like, or our geomorphological models and equations? So that's why it's I think that's at the very heart, in a sense, of the question. I do think also we need to challenge slightly, though, we have to go back a bit and challenge this difference between the purposive or cognitive mass transfer and incidental or responsive or what we might call geomorphological. Because if, for example, a terrace is built, an artificial slope is created, that is a result of a cognitive process, right, to maximise the land for cultivation or whatever. But it will affect, obviously, the erosion rate and possibly even the soil development rate as well. So we've got there's clearly an interaction between, and that's what urban hydrology has been studying after all, an interaction between processes that we study and the cognitive acts that create made ground. And so that's possibly where we need to focus a little bit more on.
Andreas, have you got anything to add to the question that's obviously stimulated a number of topics there?
Certainly we know from agricultural history many cases where people have built check dams, for example, not just to harvest water, but also to get more soil, more richer ground for agricultural purposes. So there is no clear cut between intentional and unintentional, and that needs to be incorporated, certainly.
Another question from the audience, Jackie Crow, and come to Ken Gregory.
Thank you. I'm probably a bit confused as to what we're actually debating here, but if we strip it back and say that as geomorphologists we're interested in describing the geomorphic effectiveness of processes, and we think about that in terms of work performed, all of you have talked about a common metric there of erosion, basically. So are we happy that we're sort of using that as a common metric? And secondly, geomorphic effectiveness is also assessed in terms of the recovery of the landscape. And are we implying that this landscape that we've greatly affected is beyond recovery? And both of those are a bit unclear to me in terms of where the debate is actually going.
Can I do the first one? I don't want to do the second one. I think technically we shouldn't just be thinking of erosion. We should be thinking of the differential between, at least the differential between the soil, the creation of regolith and the erosion rate. And there's an assumption out there, of course, that humans dramatically alter the erosion rate, but they don't do very much to the production of solum or the production of regolith. And I think that's a problematic assumption, that the more we get into this. So that's the first part. And I'll come over to the second part.
Let me try the second part. It depends on the time scale at which you look at it. Basically, all of that is reversible if you just wait long enough. So if you wait another 100,000 years and we have another ice age, then not much of the built-up materials in Great Britain will survive, at least not in the northern part. And that's the same for the soils in the worst areas. For example, when you get a new loess deposit and then you get another warm period and you get a new soil forming. If you think on human time scales, it's a very different matter, and certainly the floodplains, the whole fluvial systems in continental Europe there is no more natural state to them, and they will not recover on their own.
But you could go to Korea, for example, where we see spectacular examples of humans reversing the landscape just through population. They've turned river systems that were concrete into natural systems. So again, there is that propensity to sort of confuse recovery with timescales and what's involved.
But I think the key thing is what it means for the stratigraphic record.
Yes, well, yeah.
You can create characteristics which are similar to the characteristics that a system had before, but you can never put it back. Because, apart from everything else, we have organic evolution, it's linear. So you can't really do that, but you can create a mimic of our system, maybe, in certain respects.
But then you think it's very interesting when Tony was talking about this, the fact that humans as geological or geomorphological agents, there's a decision-making process involved in that. So we've all got the opportunity to influence the future geological record, which is a bit crazy. You can decide what it looks like.
This is getting drifting into Bernansky's definition of the noosphere, the realm of human consciousness shaping the Earth. But, King Gregory had his hand up over there. So.
Thank you. This follows on from the immediate discussion. But if you look back at geomorphology and its development, then amazingly, until about 1970, human activity wasn't really embraced. I know there was George Perkins Marsh, but we didn't actually acknowledge him until 1970 and subsequently. Much more recently, have we recognised that there are urban areas and that there is geomorphological work going on in urban areas as well as urban hydrology. And it seems to me that geomorphology has got to be quite convinced and quite dogmatic, following Jim Rose's point, that there are opportunities there, it's what geomorphologists are doing, and we should embrace this, not think of certain areas that are excluded.
Yeah, that's a very valuable point. Simon, do you want to kick off in response to that?
Yeah, I was just going to, on that topic actually, that there's work by people like Ian Douglas at Manchester University in the area of industrial ecology, materials flow analysis, that kind of thing. But certainly for me, it was the first area that I looked at when I realised that that kind of geomorphological work was being done. So just wanted to highlight that. And I think that the recognition. Oh, sorry, I'll pass that. I'll come back to this.
Andreas, jump in on that. No. Okay. John.
Is there anything wrong with informal definition? It seems to me that once you start trying to formally define things, you're going to offend somebody. Different disciplines are going to want to have different boundaries. Now, I see human influence as a whole series of trajectories, evolution, if you like, and putting a boundary around something is a fairly old-fashioned way of doing things. If you do put a boundary in place, suppose it's a length boundary, suppose it's a post-war boundary, that's going to leave out a lot of the archaeologists. If you put a very early boundary in, it doesn't show the acceleration of events that's happened in the past 2 decades. So I think there are dangers in converting an informal concept, which is very useful, but raises a lot of interest and debate, trying to give it a formal boundary definition. And it seems to me that historians have managed perfectly well was talking about the medieval period, about putting a line around it. Archaeologists talk about the Stone Age, which some of us are still in, including the Baptist government. So I don't see that actually a formal boundary is going to help us. It is in fact going to lead to a lot of controversy. Furthermore, if it is a boundary that's determined by, say, a recent date, that's actually going to guide funding for research into projects which concern the here and now and relatively recent. And it seems to me that that is already a problem in many areas of human impact. People don't realise how far back things go. If you put a very early date, well again, that's certainly not going to suit atmospheric chemists. So I do think
there's nothing wrong with an informal concept. Once you start formalising it,
it seems to me things become very, very difficult.
Well, I think we probably all agree with that. I certainly agree with the sentiments there. The point is, the debate is taking place, and it may well be formally ratified, and there will be a boundary set for it if they follow.
Well, in that case, should we not argue for an informal boundary if that is what people think there is?
Well, perhaps
I don't know boxing up time. I don't think that's actually how evolution takes place, by having formal boundaries. I don't think it helps us. And if we don't think it's going to help us as scientists, surely we ought to be making an alternative case for not having a formal system.
Well, archaeologists are making a very similar point of view, of course, because their whole discipline is based around some form of human impact on the Earth, of course, quite very logical. Simon, if you want to chip in on that.
Yeah, just quickly, just to clarify that the Anthropocene working group of the International Commission on Stratigraphy and its various sub-commissions is debating exactly that. So I think there's agreement that only if it's useful to do so. So it's completely taken on board that it may be informal. And the whole process of ratifying a geological boundary has to go through numerous stages. It has to be agreed, proposed, ratified. So I don't think that this is just to clarify. I don't think that there's any concern about that at all. I think that it's only if it's useful to do so.